Let's do lesson 4, Pascal's pride. Okay, we're doing division problems. And this form right here of the g at x divided into f at x means that our numerator is f at x and our denominator is g at x. So if we write this problem in that form, and we put the numerator in as x plus 7, and 2x minus 3. And my denominator is my divisor, which is x plus 7. Then you can see that this quotient will be 2x minus 3, because the common factor of x plus 7 rather cancels out in the numerator and denominator. So the next guy is going to take pretty much the same form. My numerator is f at x, 5x plus 7, negative 3x plus 11. And my divisor is negative 3x plus 11. These cancel out, so my quotient is 5x plus 7. Number 3, my numerator should be f at x, which is x plus 2 times x squared plus 3x plus 2. My divisor is g at x, which is x plus 2. See you later, x plus 2. My quotient, x squared plus 3x plus 2. Number 4, my numerator is f at x, which is 5x minus 3 times x squared minus 11x minus 9. My divisor is g at x, 5x minus 3. Quotient, x squared minus 11x minus 9. Part B of number 4, my numerator is still f at x, so that's going to be the 5x, looking at my book here, x squared minus 11x minus 9. My divisor is h at x, which is x squared minus 11x minus 9. So this time the trinomials cancel out and the quotient is 5x minus 3. Now on the next two problems, what we have to do is to factor that expression, because the divisors are going to be h at x and g at x, which is x minus 1 and 2x minus 3, and I see neither of those in f at x. But if I take, on part A, I take 5x minus 6, turns out that expression, I'll highlight it in yellow here, when I factor that expression, I get 2x with x, right? And then I get a minus 1 with a minus 3, like that. So when I divide by g at x, which is 2x minus 3, my quotient is going to be the product of the two remaining factors, the 5x minus 6 and the x minus the 1. Oops, I just did part B first. This is part B, because I divided by 2x minus 3, I divided by h at x. So that'll leave me the 5x minus the 6 and the x minus the 1. So on this part, it's 5x squared minus 11x plus 6. And I'm getting that by multiplying together the two remaining factors. All right, so now I'll do part A. Part A, so this is part B. Part A will have the numerator still be 5x minus 6 with a 2x minus 3 and an x minus a 1. But I want to divide by g at x, which is x minus 1. So these two cancel out. That leaves me these two leaves me these two factors. After the x minus 1s cancel out. And if I multiply 5x minus 6 times 2x minus 3, part A will be 10x squared minus 27x plus an 18. So that last one, number 5, we had to do some factoring. All right. Multiply together here. This is, nowadays it's called the FOIL method. First outside, inside, last. Usually the O and the I are like terms and can be combined. So on the first one here, A times A is A squared. My inner and outer are both AB, so that's plus 2AB, and then B squared. On the next one, it's x times x, which is x squared. Negative 3x, positive 9x is going to be plus 6x, and then negative 3 times 9 is negative 27. 2x times 5x on number 8 is 10x squared. Negative 25, positive 4, negative 21x. Negative 5 times 2 is negative 10. Number 9, 3x times x is 3x squared. Got a 1x and a 3x, which is a 4x. And then 1 times 1 is 1. And last, 6x times 5x is 30x squared. 35 minus 24 is what? 35 minus 24 is 11. And then minus 28. And one more here. 2x times x squared is 2x cubed. Now notice this time the inner product is negative 7x squared, but the outer product is 4x. They don't combine, and then minus 14. All right, Pascal's triangle allows us to perform powers of binomials without having to do repeated FOILs. So the pattern of that Pascal's triangle, which is right here, those are just the coefficients. You can see the binomial expansion in these cases. So if I'm doing x plus 1 to the fifth, I'm going to start off with x to the fifth. Now, since we're doing the fifth power, we need the next row. And the next row, if I get my eraser back here, the next row of Pascal's triangle is 1, 5, 10, 10, 5, 1. Okay. 1, 5, 10, 10, 5, 1. Pascal's triangle, each entry you can get by summing the two that are diagonally above it. So it always starts with a 1 and ends with a 1. So that's those guys. The 5 I'm getting by adding the 1 and the 4. And then the 10 is the 4 and the 6. The second 10 is the 6 and the 4, and so on. So using those coefficients, I'm going to have x to the fifth plus 5x to the fourth plus 10x to the third plus 10x to the second plus 5x plus 1. Okay. On the next one, the minus sign is going to cause the signs to alternate. You also have an x and a y. Last time we had a 1, so the power of 1 didn't really matter too much. So it's going to be x to the third, but then it's going to be minus, and now we're doing the third, right? So we're using these binomial coefficients. So we're going to have 3x to the second, and then y to the first. Then we're going to go to plus, and we're going to have 3 again, but this time x to the first and y to the second. That's positive there because negative y to the second is a positive value. And then finally minus y to the third. Okay, on the next one, having a 1 makes this a little bit simpler. So this is going to be, we're going to use the 1, 4, 6, 4, 1 row now. So we get 1x to the fourth minus 4x to the third. Notice the power goes down by 1, and it's a negative coefficient, the second number on that row. Then it's going to be plus 6x squared minus 4x, and then plus a 1. When you get a minus sign in the binomial, it causes the coefficients to fluctuate, positive, negative, positive, negative, positive, negative. All right, the next one, we're back to the 1, 3, 1 thing again. So that's 1x to the third. And then the binomial coefficient is 3x to the second times 4 to the first. And then plus 3x to the first times 4 to the second plus 4 to the third. So when I clean that up, I'm going to get x to the third. Then I'm going to get what? 12x squared. Check my answers here. Yep, so far so good. 4 squared is 16 times 3 is 48x. And then 4 cubed is 64. All right, using the 14641 pattern here, I'm going to have 1x to the fourth, and then my binomial coefficient. X goes down a power, 2 comes up a power, and a 6. And then x goes down a power, 2 goes up a power, and then a 4 with an x going down a power, and a 2 coming up a power, and then finally a 1 times 2 to the fourth. So this is going to be what? X to the fourth. 2 times 4 is 8x to the third. 4 times 6 is 24x to the second. 2 to the third is 8 times 4 is 32x. And 2 to the fourth is 16. Okay. So the next one, I'm going to use the 1, 3, 3, 1 pattern. 1 times 3x to the third. Now, you got to be careful here. This 3x is in parentheses. Okay, then what? Then a 3 times 3x to the second times a 1. And then plus another 3, because it's 1, 3, 3, 1, times 3x to the first, basically times 1 to the second. Doesn't matter. And then plus 1 to the third. So 3x to the third is what? 3 to the third is 27, so it's 27x cubed. This is going to be plus 27x squared, because 3 squared is 9 times 3 is 27. Then plus what? 9. 9x, 3 times 3 is 9. Okay, graphing x squared plus 2. Again, this is a little tricky I'm going to do this off the grid. X squared plus 2 is basically x squared, but up 2. Look like that. So if we did do it on the grid, it's a little tricky. I would go up to 2 right here, and then draw my parabola. Like that. Decimals here will be fun afterwards. 2 to the x, remember 2 to the x, and it comes along like that, with this hitting at 1. So the plus 2 is going to shift that up 1, 2, 3, and then it's still going to be coming in sort of like that. Right. The next one is 3 times x minus 2 squared. So the x minus the 2 is going to shift me over to 2. And then I'm going, because of the 3 there, I'm going to get a much steeper parabola like that. Now, if you have to point plot on this, 2 would give us 0, right? We made a table out of this and put a 2 in and we get 0. If we put a 3 in, 3 minus 2 right here would be 1 squared. This would give me a 6. And by symmetry, 1 would give me a 6. So I would go to 3 and 1 and plot points at the 6th level to get that graph. The next one, your basic absolute value graph, is a V-shaped graph. Each side of the graph, this side has a slope of 1, this side has a slope of -1. What we're doing here is we're shifting 1 to the right. So my vertex is going to shift over 1 to the right, and then down 2, down into here. So my shape is going to look like that. This will be the point, 1, -2. And the slope should still be 1 on each side. Okay, this guy, I'm going to shift my ordinary x squared is, the vertex is at the origin. This goes over 1, down 2, so I'm right in here. And then I've got a half, which is going to widen out my parabola quite a bit. So it would be kind of like that. And my x-intercept on this side will be 3, and on that side will be -2. If you're curious how we're getting those, I would take 1/2 of x minus 1 squared minus 2 and set it equal to 0 to see where it's at the 0 level. So your x minus 1 squared would equal what? You'd add a 2 and multiply by a 2. You'd have a 4 here. So that means your x minus 1 is 2, or your x minus 1 is -2. This is where the 3 is coming from, right here. And this is where the negative should be -1. My bad. This should be -1 right there. Okay, so that's your ready, set, go on lesson 4 from unit 3.